Hello, in this video what I'm going to do is review some linear equations, a couple concepts. We'll go over slope between 2 points and then writing an equation in slope-intercept form. I'll also mention the distance and midpoint formula. We'll be graphing a line in slope-intercept form, doing a couple of composition problems, and then getting to linear regression and making predictions based on that linear regression equation. So I'll get started right away with these slope problems and the slope formula, which is taking the difference of y values over the difference in x values. And it doesn't matter which one I call x1, y1 or x2, y2, as long as we stay consistent with it. So I'm going to substitute these values into my formula and first subtract my y's. Oops, this should have said y1. Alright, so I'm going to substitute these values in and have 3 minus 5 over my x values, which should be my negative 1 minus 5. My numerator would simplify to negative 2, and the denominator becomes negative 6. And I can simplify this fraction. It's a negative over negative, so it'll end up being a positive 1/3. So like I said, I'll end up doing the slope-intercept form, and then we'll do the distance and midpoint all in the next set of points. So with these two, I'm going to first calculate the slope between them. So even if I want to write the equation, what I'm going to do first is take my 1 minus negative 5, which would be subtracting my y values, and then divide that by the difference in x values, which is going to be 2 minus negative 2. And just be careful with signs here. The 1 minus negative 5 is going to become 6, and the 2 minus negative 2 is going to be 4. And 6 over 4 can be simplified into 3 over 2. So I have a slope of 3/2, and what we want to do in order to write this in slope-intercept form then is figure out what my y-intercept is. So I'm going to pick one of these 2 points, and I'll just pick the one with the positive values, and I'm going to call this the x part of the coordinate, and then the 1 is the y part, and I'm going to use this slope, and what I'm going to do is substitute some values into my slope-intercept form equation. So in for the y value, I'm going to substitute my 1. The m we know is 3/2. My x value comes from the coordinate, which is 2, and what that does is it leaves us with the plus b. So we want to find that b value, which is the y-intercept. So taking a look here, I have 3/2 times 2. 2's could cancel out since I have 1 on the denominator and 1 on the numerator here. So I'm left with 1 equals 3 plus b, and what I'll do is subtract 3 on both sides. And b is going to end up being 1 minus 3, which is negative 2. So what I can do then is write my equation in slope-intercept form using the 3/2 as my slope and the negative 2 as my y-intercept. So my equation becomes y equals 3/2 x minus 2. So this is going to be the equation that we'll be graphing in the following problem. What I wanted to do real quick is just go over distance and midpoint. So the midpoint formula is really just finding the middle of these 2 points. If we were to plot these on a coordinate grid, you can imagine negative 2, negative 5 down here somewhere, and then 2, 1 up here. So we want to find what's in the middle, and then I'll also go through what the distance is between the 2 points. So first one of those two, and I'm going to kind of just clean this up a little bit. I want to keep my equation. Like I said, the next part of this, what we'll do is graph this line. So I'm going to put this off to the side. The midpoint formula is really just averaging your x and y coordinates. So what I'm going to do is take my x1 plus x2 divided by 2. So I'm going to add my x coordinates together and divide by 2, and do the same thing. Do the same thing for y's. Take y1 plus y2 over 2. And what that's going to do is, again, find the average or your mean of those 2 x values and the mean of my y values and determine what's in the middle. So I'm going to substitute the values for my x's in. And first I'm going to take negative 2 plus 2 divided by 2, so it's averaging these. And then same thing for the y's. I'm going to take negative 5 plus 1 divided by 2. So averaging the x's, averaging the y's. This one, negative 2 plus 2 is 0. And here, negative 5 plus 1 is negative 4. So what I'm going to end up with then is 0 divided by 2, which is 0. And negative 4 over 2, which is negative 2. So the middle of those 2 points would be at 0, negative 2. And the other part that I wanted to do then was the distance formula, which it's pretty much the Pythagorean theorem. I'm going to take my x2 minus x1 and square that, plus the y2 minus y1 and square it. And what this is doing is giving you the horizontal distance of your x's, the y part is giving you the vertical distance, and what we're really doing then is figuring out the hypotenuse. So it is just like the Pythagorean theorem, and we're just going to be substituting some numbers into it. So again, this is x1, y1, and this is x2, y2, and we'll just start substituting some values. So I'm going to end up with 2 minus negative 2 squared plus 1 minus negative 5 squared. So again, just substituting the values from the top, I'm going to simplify this. 2 minus negative 2 is going to give me 4, and then the 1 minus the negative 5 is going to give me 6. So I can simplify this further into 16 plus 36, and I'll just slide down a little bit here, and then that's going to end up being the square root of 52, which we could go to a calculator and round, but it would end up being 7 point something for our distance between the 2 points. So just to again check that this is, first part we did was finding the middle of the 2 points, and then the second thing we did was find the distance. So what I want to do is take the equation of this line that we had from the beginning of the problem, and what we're going to do is graph it on the following problem. So what I want to first do is identify the slope of this, and the slope is the 3 over 2, and my y-intercept is negative 2. So what that means is on the y-axis we're going to start at the point 0, negative 2, and then we're going to go for my rise over run. My rise is going to be up 3 from that point, and my horizontal run would be positive 2. Or I could have said this is the same thing as having a negative over a negative, which is also positive, and this would imply going down 3 and then to the left 2. Either way, both of those points are going to be on the same line, which is going to be drawn through like this. Throw some arrows on there to make it a line, and that is it. So then moving on to composition, this is where we're going to take a value. So I would read this as f of g of 1, and we're taking that value of 1 and substituting it into my g function in for x, and we'll evaluate that function, get a number, and then substitute that number into my f function. So what I'm going to do is work from the inside out, starting with g of 1. So g of 1 equals 2 times 1 minus 4. So substituting it in for x into this equation, simplify, that's going to give me 2 minus 4, which is negative 2. So now that output of my first function becomes the input of the second function. So now I know that this g of 1 really came out to negative 2, so now I want to evaluate f of negative 2. And that means I'm going to take the negative 2 and substitute it into my f equation. You could put this in a calculator, but just be very careful that you're putting that input value in parentheses. I'm going to just do the order of operations here. The negative 2 would be squared first, and negative 2 times negative 2 is going to give me positive 4. And then evaluate. Negative 3 times 4 is negative 12, and negative 12 plus 2 is negative 10. So that would be our answer then, is the composition of f of g of 1 would give us negative 10. So we'll do another one of those, and we're going to reverse the order here and do g of f of 4. So what I'm going to do is evaluate that inside function first, the f of 4, and that's going to give me negative 3 times 4 squared plus 2, and then we'll take that value and substitute it into the g function. So order of operations would have me do the 4 squared first, which is 16. And then I'm going to multiply these two values. So negative 3 times 16 is negative 48. And then I'm going to add 2 to that. So the output of my first function is negative 46. And that output is going to now become the input for my second function, which is the g function. So what I'm going to evaluate now is g of negative 46. So negative 46 is going to become the input here. And do our multiplication first. I have 2 times negative 46, which is negative 92. And negative 92 minus 4 is negative 96. So the composition, again, you're evaluating the first function, which is the inner function. and then the output of that becomes the input of whatever the outer function would be. So I could even throw something at you that would say like f of 1, and you'd still evaluate the 1 for the f, and when you get an output, you would substitute that right back into the f function again. So just following that order of working from the inside out. And then the last problem that we'll go through, so this is a longer problem. What we're going to do is take a look at the enrollment of a school since 2005. So this is the number of years. So this would represent in 2006, 7, 8, 9, 10, okay, and so on. And the enrollment is increasing. So what we're going to do is figure out an equation that would model this situation. And we're going to go to the calculator for it. So, alright. So what I'm going to do is turn the calculator on. Oops, there we go. Alright, clear it out, and we're going to first turn our stat plot on. I'm going to go to second, and I'm going to go to y equals. And I want this first plot to be turned on, so I'm going to select enter, and then I'm going to select enter again. And I'm going to make sure that I have L1 and L2, because that's where I'm going to store these two lists. And once I make sure that that's on, I'm going to just click the y equals on the top left, because the next thing I want to do is make sure that there aren't any equations in here that would show up on my graph. So I'm all good to go. So I'm ready to enter data. I'm going to press stat, and my first option is edit. I'm going to select that, and I'm going to enter in these values. Oops. So I have 1, 2, 3, 4, 5, and 6. And then I'm going to go over and enter these values for the enrollment. So I have 961, 998, 1026, 1051, 1072, and 1104. So take a minute. You can pause if you have to, enter in that data. And then I'll keep going on with the regression equation. So my next step would be to press stat, and then I'm going to go over to calculate, so hit the right arrow, and I'm going to go down to this fourth option, which stands for linear regression AX plus B, which is the same thing as MX plus B. Instead of using M for slope, they're using A. I'm going to select that, and on these newer operating systems, these options will show up. If you just have a cursor flashing with the lin reg, it's probably an older operating system. You can go ahead and just press enter. The rest of us, we're going to scroll down to calculate and select that. And here's my my two values for this equation. So I'm going to also round to the nearest person. So I'm going to be rounding down to 27 here for my A value, and my B value I'm going to leave at 939. So I'm going to write down my equation then. Oops. So my equation would say y equals, and my A value is 27, so we would say 27x plus my y-intercept, which is 939. So just taking a look at these values, your y-intercept would be, if I had a 0 value up here, this would be approximately 939. And I say the word approximately because that wouldn't be the exact enrollment in 2005. These were all the exact values. So anytime we use this equation, it's only going to give us approximate values. So that's the next part of this, which is interpreting the slope and y-intercept. And again, our slope was the 27, the y-intercept was 939. So I'm going to just type this out here and say that the slope is 27, which represents the approximate increase in enrollment of the high school per year. So they're getting about 27 more students every year. If it would have been a negative value, they'd be losing students, and that's not the case. The y-intercept is 939, which represents, and this is huge as well, the approximate enrollment in the starting year, which is 2005. So we're collecting all that data from the years after 2005. 939 just represents the approximate starting amount. So what we're going to do is determine the enrollment in 2017. So I'm going to use that equation again, y equals 27x plus 939. And what I also want to do real quick is just show you when we turned our plot on, what that does is I could hit this zoom across the top in the middle. If you press the number 9, it's going to show you where your data shows up. And the other thing I can do is go to y equals and put in my equation. So y equals 27x plus 939. And if I hit graph now, it's going to draw my trend line through there. So we can see where it starts on this y-axis, and then every one of these years past that just represents another year of enrollment that's obviously increasing. So we could use this to make predictions. We would have to zoom out a little bit, but I'm going to do it all algebraically. So first big mistake would be if I threw 2017 in for my x value, because what that would represent is 2017 years past 2005, and that's not what we want to do. 2017 is a time value, but we want to know how many years since 2005 that is. So what I'm going to be doing is taking 2017 minus 2005, and it tells me that we are going to make an approximation for the enrollment 12 years later. So I'm going to go to y equals 27 times 12 plus 939. So this is assuming that we're adding 27 students each of the 12 years, and then so what I'm going to do is take my 27 times 12, and that tells me that in that 12 years we've added 324 students on top of my existing 939. So I'm going to add that value to it and get 1,263 students. So that'd be my approximate enrollment in 2017. And the next question would kind of flip-flop the logic. It's asking when is the enrollment going to reach 1,500 students, and that's where we're going to substitute the 1,500 in for a y value in my equation and then solve for x. So the first thing I would do is that substitution, since I'm giving an enrollment value, which is a y value, and we're going to work backwards and figure out what my x is. So the first thing I'm going to do is subtract 939 on both sides of this, and what that's doing is getting rid of my original enrollment in that first year. So that's going to give me 561. And what we're really asking ourselves is, okay, if we grow 27 students every year, how many years is it going to take to get an additional 561 students? And I'm getting 20.78. So that's not in the year 20, so what we need to do is think about, all right, we started collecting data in 2005, so I'm going 20.78 years past that. So we're going to add that to really figure out what the year is, and then this would really represent the year 2025. I could say 0.78, or we could say it's going to take between 2025 and the year 2026 before our enrollment reaches 1,500 students. So just to quickly recap all of this process then, we substituted the data into the calculator. We got the linear regression equation, which told us the approximate enrollment in 2005 and the approximate increase in population, and we interpreted both those. And then we ended up substituting a value in for x and evaluating and solving, or substituting a value in for y and then also solving.